everybody, this is Mr. Walsh, and today we're going to be talking about the properties of the elements, which is a kind of a precursor to our periodic trends unit or section here. Okay, so this is going to wrap up Unit 2, and it's basically using the periodic table to understand what kind of properties elements have. And so that's really the goal of this, is understanding the periodic table and making predictions based on the periodic table. So what we know is the periodic table has this stair step, and the stair step divides the periodic table, I'd say, in half, but it's not really in half. Okay, so anything up here are nonmetals, and down here are metals, and if it touches, and I'll kind of highlight these here. Okay, if it touches the stair step, it's called a metalloid, with the exception of aluminum. Aluminum is not a metalloid. Aluminum is considered a metal. It's got all the characteristics of a metal. So what makes these things different? Well, here we go. Metals are shiny and ductile, and you guys can pause the video and write this down, or you can go find the slide in Google Classroom. But okay, we have metals that conduct heat and electricity. That's why metals are made out of wire. Okay, has a high melting point. Metals typically will melt at very high melting points, like tungsten melts at like 6,000 degrees or something like that. Okay, and now they also form these positively charged ions. And remember, positively charged ions are called cations. Okay, and then opposite, because metals and nonmetals are opposite, instead of being shiny, nonmetals are dull, or they have low luster. Luster actually has a scale. This is the number. So if it has low luster, it has a low lustrous scale. Okay, instead of being able to be drawn into wires and being pounded with a hammer, they're brittle. If you hit a nonmetal with a hammer, it's gonna shatter. Okay, they use nonmetals as insulators, and they have low melting points, and they form these negatively charged ions, which we call anions. Okay, and then metalloids, which are in between, and they are literally located in between here on the stair step, have properties that are kind of in the middle. Metalloids are kind of shiny. Sometimes they're kind of dull, though. They can be, brittle, but they can also be drawn into wires sometimes. They're not very good at conducting heat and electricity, but they do it all right. Like silicon. Silicon is a metalloid, and that's the basis of our computer chips, because it kind of conducts electricity, but it kind of doesn't. So it makes it good to make computer chips out of. Okay. And then they have in-between melting points, and here they can form either positive or negative ions, and that's what metals do. Okay, or that's what metalloids do. So here, let's. I've alluded to this, but now I'm going to make it. We're going to figure out how many valence electrons there are. Super easy. So we're going to write the electron configuration of sodium and potassium. Okay. So sodium, 1s2, 2s2, 2p6, 3s1. Potassium, we start the same way. And then here we go to 4s1. So if we look, each of these things have one valence electron. They have one valence electron. Okay. They are actually also in group 1. Okay. And I tried to allude to this when we did Bohr models and all this stuff. So group 1 has one valence electron. So here's how to quickly determine the valence electrons. If you're in group 1, it's going to have 1. If you're in group 2, you're going to have 2 valence electrons. All of these guys here and even the F block down below, they all have 2 valence electrons. That later on in other chemistry courses, that may change and you may whatever, but we're just going to stick to 2 for now. Okay, and then here we have 3 valence electrons and 4 valence electrons and 5 valence electrons, 6, 7, and with the exception of helium, because this first row only has space for 2 electrons, everything down below here has 8. It still has a full valence. Okay, so this is a full valence, but in the first energy level, you only have space for 2 electrons. So if you want to know how many valence electrons something is, you just really have to be able to read the periodic table and look at what group number it's in, and that makes it super straightforward. Okay, so this is patterns in the periodic table, right? This is what we're getting into. So there you have it, everybody. Your introduction to kind of patterns in the periodic table. Have a great day.